One of the major differences between Mars and Earth is what happens beneath the surface. Our planet is still a tectonically and volcanically active world, as evidenced by the current eruptions in Hawaii, whereas Mars has been a cold, geologically dead place for the past 3 billion years. There are currently no active volcanoes on Mars. However, long ago, eruptions created massive volcanoes and ash piles. This changes the shape of the planet's geology. How did this happen? When was Mars last volcanically active? When did Mars stop being volcanic? Today we're going to the Red Planet. So stay tuned and watch till the end to see the past, present, and future missions to Mars.
Audio Jungle.
Some volcanoes can erupt with such force that oceans of dust and toxic gases are released into the atmosphere, blocking sunlight and altering the planet's climate for decades. Scientists recently discovered evidence for thousands of such super-eruptions, the most violent volcanic explosions known, by studying the topography and mineral composition of a portion of the Arabia Terra region in northern Mars. Mars's crust is not broken into moving plates as it is on Earth. Over many millions of years, rising plumes of heated rock from deep below built massive volcanoes. The majority of Mars's volcanism occurred between 3 and 4 billion years ago, leaving behind massive monuments such as Olympus Mons, the solar system's tallest mountain. Olympus Mons is roughly 3 times the height of Mount Everest, which is 16 miles, 25 kilometers. What is even crazy is, previous research suggested that the Red Planet flared with smaller volcanic eruptions as recently as 2.5 million years ago. But the surprising thing is, scientists have discovered evidence that Mars is still volcanically active, with signs of an eruption occurring within the last 50,000 years. So, what is the role of volcanoes in shaping Mars's geology? Volcanic activity has played an important role in the geologic evolution of Mars. Scientists have known since the Mariner 9 mission in 1972 that volcanic features cover a large portion of the Martian surface. Extensive lava flows, vast lava plains, and the solar system's largest known volcanoes are among these features. Earth and Mars are both large, differentiated planets made of similar chondritic materials. But some things are similar. Many of the same magmatic processes that occur on Earth also occur on Mars, and the igneous rocks and minerals on both planets are similar enough in composition that they can be given the same names. The planet was moved by powerful volcanic activity. Yes, you heard correctly. The Tharsis volcanic dome, a large volcanic structure, caused the Red Planet's surface to tilt by 20 to 25 degrees 3 billion to 3.5 billion years ago. Tharsis is home to our solar system's largest volcanoes, and because of their size, they were able to spew out so much lava that the outer layers of Mars rotated around its core. Imagine having a peach and twisting the flesh around the pit. That's what happened to Mars. Tharsis Dome formed 3.7 billion years ago, and hundreds of millions of years of volcanic activity resulted in a billion-ton plateau on Mars. This mass was so massive that it caused the planet's mantle and crust to swivel, shifting the planet's poles and shifting the Tharsis Dome onto the planet's equator. Curiosity rover deserves credit for contributing to our understanding of Mars's volcanic past. Don't you agree? Revealing the potentially habitable climate of ancient Mars is an important part of NASA's mission to explore and understand the unknown in order to inspire and benefit humanity. And the Curiosity rover has been on the case on the Red Planet for the past 10 years. But we are lucky because based on these data, researchers have discovered that a mysterious Martian mineral that has perplexed scientists since its discovery 7 years ago may have been spat out during an unusual volcanic eruption. The mineral, which is normally found only on Earth, was most likely formed on Mars more than 3 billion years ago. On July 30th, 2015, NASA's Curiosity rover discovered the mineral inside a rock at the heart of the 96-mile-wide, 154-kilometer Gale crater. The rover drilled a small hole in the rock and extracted a sample of silver-colored dust. The dust was analyzed by Curiosity's onboard X-ray diffraction laboratory, which discovered tridymite, a rare type of quartz made entirely of silicon dioxide, or silica, that is formed by certain types of volcanic activity. The unusual discovery was completely unexpected. The researchers are still unsure of the location of the volcano that gave birth to the tridymite sample on Mars. It could have been caused by a small nearby eruption or a massive explosion much further away. It's difficult to find past volcanoes on Mars because it's difficult to tell the difference between impact craters and volcanic calderas that have been eroded over billions of years. The researchers also had to explain how tridymite formed on Mars, which is thought to have very different conditions than Earth. Previous evidence from Mars suggests that the volcanic eruptions on the red planet were basaltic, with low silica content. This is because Mars lacks tectonic plates, which are the primary source of Earth's silica-rich eruptions. Further examination of the tridymite discovered on Mars revealed that it differed slightly from the tridymite found in Earth's volcanoes. This suggests that the Martian version evolved under slightly different conditions. According to researchers, the tridymite discovered in the Gale crater was formed over time with a magma chamber beneath the unknown volcano, according to researchers. According to the study, the temperature within the chamber would have been slightly lower than in tridymite-forming volcanoes on Earth, but the team believes this may have allowed the mineral to slowly form as more silica became available. But we are lucky that future discoveries from Curiosity and its successor, the Perseverance rover, as well as Martian rocks brought back to Earth by NASA's proposed Mars Sample Return mission, could shed more light on Mars's ancient volcanic past. What do you guys think? There are many mysteries to be solved, but let us hope for the best. Thanks for watching, and see you in the next video.